a heat and temperature problem. So we have our heat Q is equal to our mass times our specific heat capacity times delta T. In this problem, we're asked to solve for the mass of the sample. So we're going to solve this equation for M. And we have M is equal to our heat divided by our specific heat capacity and delta T. So we need to determine our delta T. Delta T is always TF minus TI. In this situation, we have to be very careful with signs because we have our final temperature of minus 21 degrees C, and from that we'll subtract a negative 25 degrees C. So this equals a temperature change of 4 degrees Celsius. Okay, it might be easier to see graphically. If we have our initial temperature and our final temperature, we know we're increasing in temperature from a minus 25 degrees C up to a minus 21 degrees C. So it is going to be a positive temperature change, a delta T. So just be careful, make sure you always have the right convention, TF minus TI. Let's substitute our values in and solve this problem out. Our heat is 59 joules. Now we divide by both delta T and our specific heat capacity. Our delta T we determined was 4 degrees C, and now we divide by the specific heat of solid water in joules. I have to find that value. Okay, remember not to panic because these values will be given to you. Okay, 2.08 joules per gram degrees C. So this is in the denominator. Now let's go back down to the problem here. Our specific heat capacity, and this is in the denominator, 2.08 joules per gram degrees C. And if we look at our units, we see degrees C cancels, joules cancel, and the units of grams survive. So we're calculating a mass. So we do the math that's indicated. We have 7.091 grams. Now we'll go back and determine sig figs. We look at all the numbers that go into our answer. Okay, we're going to be limited here to only one sig fig in our final answer. But let's show you all of this. Okay, we have one sig fig here, 2, and 3 here. So we can only use one sig fig in our final answer. So we have our final answer of 7 grams.